Welcome, ladies and gentlemen. Welcome back to another tech day. Today, I'm gonna do a little bit of an inversion. I'm gonna start with some really cool links. Then I'm gonna do some machine learning. Afterwards, maybe some software engineering, some architectural tips and points. Let's see. But I promise you, we're gonna have a great 2 hours, 2.5 hours or so. So let's start. What I wanted to start with is the following thing. I have no idea about the context of all of this. So I'm just gonna start reading, and hopefully we're gonna fill the blanks as we go on. Okay, here's a problem that sounded impossible. I almost regret posting the story to a wide audience because it makes a great tale over drinks at a conference. Story is slightly altered in order to protect the guilty. Allied, I never heard about this word. Allied over irrelevant and boring details and generally make the whole thing more entertaining. I was working in a job. I love this. You had a paragraph with some background information with a hook, and then it starts immediately without a message to our sponsors, without any site links and stuff like that. We immediately hit it from the get-go. I was working in a job running the campus email system some years ago when I got a call from the chairman of the statistics department. We are having a problem sending email out of the department. What's the problem, I asked. We can't send mail more than 500 miles, the chairman explained. I choked on my latte. Come again. We can't send mail further than 500 miles from here, he repeated. A little bit more, actually. Call it 520 miles, but no farther. Email doesn't really work like that, generally, I said, trying to keep the panic out of my voice. One doesn't display panic when speaking to department chairman, even of relatively impoverished department like statistics. What makes you think that you can't send mail more than 500 miles? It's not what I think, the chairman replied testily. Testily? In a petulant manner. What? English is not my first language, so... Testily means angrily or in an irritated way. Okay. You see, when we first noticed this happening a few days ago, you waited a few days, I interrupted, and you couldn't send emails this whole time. We could send emails, just not more than 500 miles, yes. Why didn't you call earlier? Well, we hadn't collected enough data to be sure of what was going on until just now. Makes sense. Statistics, am I right? Anyway, I asked one of the geostatisticians to look into it, and she produced a map showing the radius within which we can send emails to be slightly more than 500 miles. There are a number of destinations within that radius that we can't reach either. Or we can reach them sporadically, but we can never email farther. Is it farther or further? Yeah. ESL school with the Duke. Is it further or farther? Merriam-Webster. Is it further or farther?
Farther.
Farther. Am I... Do I have sound?
Farther.
Farther. And what's this? Further.
Further.
Too much. Let's go back. So, before I continue, let me stop and think about it. What could cause this? What could be the snowball that created all of this mess? Is there even a snowball? Okay, it started a few days ago. So this is how it started. The consultant came and patched our server and rebooted it. But I called him and he said he didn't touch the mail system, of course. The good old, I did change stuff in my domain, but I never touched the other systems. Okay, let me take a look and I'll call you back. What could cause this? 500 miles. I logged into their department server and sent a few test mails. A test mail to my own account was delivered without a hitch. Richmond and Atlanta and Washington worked as well. Princeton as well. But then I tried to send an email to Memphis and it failed. Boston failed. Detroit failed. New York worked, but Providence failed. I was beginning to wonder if I had lost my sanity. I tried emailing a friend who lived in North Carolina, but whose ISP was in Seattle. It failed. Now, I'm trying to visualize this, but where is the USA? I tried emailing a friend who lived in North, but where are you from? Where are you from? Where are you from? No idea. No idea. Okay. Doesn't matter. I took a look at the send mail CF file. So CF means configuration, send mail. What's this? Is this the... I assume this is... I think I have this on my own system. It's a protocol or maybe agent, which is used to send and route emails. It basically just routes, delivers and forwards emails over networks. It's configurable, it's powerful, it's also really complex. I don't know if we have an example of it. No. DuckDuckGo. Okay. Wow, it's slow. An example of send mail. Where is the example file of this? To example, this is send mail MC, but where is send mail config? No. Okay, doesn't matter. Maybe the problem is not there. It looked fairly normal. It looked familiar. I diffed it against the sendmail CF in my home directory. It hadn't been altered. It was a sendmail CF I had written, and I was fairly certain I hadn't enabled the file mail over 500 miles option. At a loss, I telnetted into the SMTP port. The server happily responded with a Sun OS sendmail banner. I hadn't enabled the fail mail over 500 miles. Yeah, maybe there's a secret setting for this somewhere. So what they did, they manually connected to the mail server's port using telnet to test or observe some behaviors directly. All right, wait a minute. A Sun OS send mail banner. At the time, Sun was still shipping SendMail 5 with its operating system, and even though SendMail 8 was fairly mature. I standardized on SendMail 8. Also being a good system administrator, I had written a SendMail CF that used a nice long self-documenting option and variable names available in SendMail 8 rather than the cryptic punctuation mark codes that had been used in SendMail 5. Ah, alright, so when the consultant had patched the server, he apparently upgraded the version of Sun OS, and in doing so downgraded SendMail. The upgrade helpfully left the SendMail config alone, even though it was now the wrong version. Okay, so SendMail 5. So the SendMail 5, or the version that Sun shipped, could deal with SendMail 8, SendMail CF, but the new configuration options, those it saw as junk, it skipped. And the SendMail binary had no defaults compiled in for most of these. So finding no suitable settings in the SendMail CF file, they were set to 0. One of the settings that was set to 0 was the timeout to connect to the remote SMTP server. Alright, some experimentation established that on this particular machine with its typical load, a 0 timeout would abort a connect call in slightly over 3 milliseconds. So what happened is actually, okay. Another feature was that it was 100% switched and outgoing packet wouldn't incur a router delay until hitting the POP and reaching a router on the far side. Okay, so you have 3 millilight seconds, you want miles, it's 500 miles, or a little bit more. So what happened here is that the server ran SendMail 8. It supported certain options, human readable configs. And the system was patched by a consultant, and the patch updated Sun OS. But in doing so, the consultant downgraded SendMail back to version 5, which did not understand some of the options, right? So SendMail was still using the existing SendMail configuration, but it ignored some configs, and if it ignored some configs, they were set to 0. So many critical settings were effectively set to 0. One of them being the timeout.connect, which is the SMTP connection timeout. When it's set to 0, any attempt to connect to a remote mail server would give up almost immediately, within 3 milliseconds. Now, on the campus network, you can, of course, you can locate the local servers and reach them instantly, because it's mostly LAN switching. But remote servers would require more than 3 milliseconds for a round trip, simply due to the speed of light and router delays. So connections that are far away were being dropped before they had time to complete. So basically what we did here is we converted 3 milliseconds that were going at the speed of light into miles, and we get 558 miles. Interesting and cool. How long are we running for? 20 minutes. Let me do another link. Now look at this. Here it says, teach yourself programming in 10 years. Peter Norvig. Okay, walk into any bookstore and you'll see how to teach yourself Java. So this is another article that I'm gonna read. And most probably I'm gonna start with 2 articles, and then I'm gonna be using the knowledge here and I'm gonna apply it into my machine learning road. All right. So bookstores have these teach yourself Java and stuff like that in one in one day or 24 hours. Top 10 9 are programming books. Okay. The conclusion is that either people are in a big rush to learn about programming or that programming is somehow fabulously easier to learn than anything else. This makes sense. This makes sense, man. I remember when it was hitting the high notes back in I don't know, 2018 to 19. Everyone, my grandmother wanted to learn how to program. And it's not that people can't do this, but I don't think it's as simple as people think it is. How to design programs. When they said bad programming is easy, idiots can learn it in 21 days, even if they are dummies. Okay, when was this written? 2011 to 2014. Let's analyze what a title like Teach Yourself C++ in 24 hours could mean. Teach yourself. In 24 hours, you won't have time to write several significant programs and learn from your successes and failures with them. You won't have time to work with an experienced programmer and understand what it's like to live in a C++ environment. You won't have time to learn much, which is true, basically. It is true. A little learning is a dangerous thing. A little knowing is a dangerous thing as well. This doesn't exist anymore. Is this existing? Teach yourself programming in 10 years. Okay, we have a couple of researchers. They have shown that it takes about 10 years to develop expertise in any of a wide variety of areas, including chess playing, music composition, telegraph operation, painting, piano playing, swimming, tennis, and the research in neuropsychology and topology. The key is deliberate practice. So, not only mechanically repeating it, but challenging yourself with a task that is just beyond your current ability, trying it, analyzing your performance, and correcting any mistakes. Then repeating and then repeating again. All right, I read a book actually on this. Malcolm Gladwell. What was the name of this book? Where is this guy? Outliers. Yeah, this is the book. Samuel Johnson said excellence in any department can be attained only by the labor of a lifetime. Yeah, I mean, this makes sense. This makes sense, brother. So what if you want to be a programmer? Get interested in programming and do some because it's fun. Yeah, tip number 1. Program. Learn by doing. Talk with other programmers. College. Wait, this will give you access to some jobs that require credentials. Yeah, I think in the end, college is, apart from professions that really require a certain certification, like doctors, surgeons, or lawyers. I don't know how. I don't know if someone is gonna is gonna be insulted because I also have a college degree, but I don't know how useful it is. I really don't. Computer science education cannot make anybody an expert programmer any more than studying brushes and pigments can make somebody an expert painter. Yeah, that's it. DNA Lounge, what is this? Jamie Zawinsky, a former Netscape programmer. Oh, cool. Work on projects with other programmers. Be the best of them on some projects, be the worst on some others. work on projects after other programmers. Makes sense. Learn at least half a dozen programming languages. Remember that there's a computer in computer science. Get involved in a language standardization effort. It could be deciding if your local coding style will have 2 or 4 space indentation levels, but also at the same time have a good sense to get off the language standardization effort as quickly as possible. And book learnings. It's a question of how far you can get just by book learning. Okay, here we are. Let me just go back. Let me go back to batch gradient descent. Okay. So what this is gradient descent applied to linear regression. And this is the OG code right here. So what we have here is ETA, which is it tells us how big a step we take each iteration towards the minimum. Basically, we are looking at if we are looking at the smallest possible error. In this case, we are making steps this big each iteration towards reaching that minimum. We also have, let me just turn this off. We also have the number of epochs, how many steps we totally take. This is the number of training examples. Okay, so let's say we have, how can I just do this? Can I just do this? Yes, but how can I move? I think I'm gonna use this way instead of projecting directly to OBS. But let me just see how can I move. So if I click Alt, click and drag with left mouse button anywhere. No, this doesn't work. Is it this Alt? One of these Alts. It's not working. Okay, it's Alt and F7. Okay, here we are. Nice. Okay. So we also have our number of training examples. Let's say we have this. This is our number of training examples like we have here. Length XB. Maybe I should just zoom out a bit. Just a tiny bit. Okay. So let's say this is an NP array that looks like this. We have 1, 50. This is supposed to be 50. 1, 60. 100. I think I already went through this, but I think it's okay. 120 to go over this again. So this is our vector right here. It looks like this. So M in this case should be 5 because we have 5 data points. Okay. So the theta is gonna be random because we pick it up from MP random. So in our case, we have gotten this values right here, which are 0.4967, comma minus 0.1382 8, 2, 6, 4, 3. All right. So here, for each of these epochs here, we first can do this one. I don't want to select this because every time I select, I move my tablet screen here. But what's happening here is that we start writing. So what we will have this formula, which is probably wrong. 0.4967 plus this is going to be minus 0.1382 times x. This is probably incorrect, but we will fix it using gradient descent. And now we need to run gradient descent, which is all of these 4 loops right here. So what we do is let's start with this that I selected. I have xb, which does a matrix multiplication on theta. So if I print this out, I think I can also print this out. Wait. I'm gonna do print. Wait. F iteration epoch wait. Up. I can do this. And I can do this. What will happen if I run this? How is this not defined? Do I need to put $? Here? I think I need to put $. Will it work now? No. Why? I need to run everything above. That's why it's not working. And now if I run this, okay. I also don't need $. Here. I don't need the theta anymore. I don't need $. I don't need $. Here as well. If I run it again. Wow, there's a lot of examples here. Okay, let's do a simple one. Let's do a gradient descent using a simplified dataset with like 5 points and 5 iterations. So let's move all of this here. So let's say we want to find the best line to fit this data. I have the x. And what are we gonna have? We're gonna have 1, 0, 2, 0, 3, 4, and 5. And y is gonna be 3, 7, 9, and 11. So what's the relationship? The relationship is y is equal to 1 plus 2 times x. All right. So this is the relationship between this data. So what we want to do, we want to find theta 0 is going to be 1, and theta 1 is going to be 2. So this is the simplest possible explanation that we can find. So what we want to do is I'm going to create x underscore b, and this is just going to be the same matrix here, but the only difference is we're going to add a 1 to each of these. 1.0, 1, 2.0, and so on and so on. I don't want to write this. Let's say we also have theta. It's going to be randomly 0.5, 0.5. Now, let's do the gradient descent on 5 iterations. So our ETA is 1, and our M is 5. Okay, so let's see. Our prediction will be x multiplied by theta. Wait, I can also write it here, I think. Wait. Let's put my xp to be this. I'm gonna put my ETA to be 1, and I'm gonna put the number of epochs to be 5. Theta, I'm gonna give it these params right here. Let's say they are produced randomly, even though they are not. And if I run this now, list object has no attribute t. Where? List attribute has no. It's this one. Ah, okay. So I need this to. I don't want this to be a list. I don't want this to be a list. What's this? ND array. How do I create ND arrays? MP array. How do I create arrays, brother? Where's the error? So I think it's gonna work now. Operands cannot be broadcast together with shapes y1, which is this guy, and 101. What is the 101? Is it theta? No, it's y. Ah, I also need to create a y as well. Wait. Okay, and now okay, let's now continue our journey here. So ETA is 1, not actually 1. Let me give it 0.1. And now I have no idea what's happening here, man. But let me try to. So all right, so this is the first iteration here. Wait. This is the first iteration here. So iteration is 0. And our so our x underscore b, or this is a multiplication of a matrix by a vector, will be just a second. It's gonna be 1, 0, 1.5, 2, 2.5, and 3. Now, then I calculate the error because I then this is my prediction. So I subtract y from it. So if I subtract y, and if my y is 3, 5, 7, 9, and 11, so I'm gonna say 1 minus 3 is minus 2. This is gonna be minus 3.5, minus 5, minus 6.5, minus 8. And then I create the gradients. Then I create the gradients. I use this formula. It's gonna be 2 over 5 because we have 5 elements, right? 2 over 5, and we multiply this by the transpose of xb. Wait, I should also print the gradient as well. Wait. Print f gradients. So this is the transposed x matrix. All right, so this is the matrix multiplication. It should produce, what will it produce? What is the size of this? So it should produce most probably. Here it's a 2-element vector, right? And then after this, I say, okay, what is theta? Theta is eta times the gradients, which are these. Wait. Let me print all of this. Let me print all of these values. I want to make sure I'm not print. I feel like I'm really close to getting it. I want to really get it. I don't want to just learn things. I think people who do things mechanically are not. Why? Okay, maybe like this. So theta is 1, 5, and 4, 1. There's something wrong. I think in the end the theta should be 1 and 2. But there's something wrong. This is really weird. It's not working as it should. Crawlable element iteration 999. There's something wrong here. So what is happening here? What is happening here? Why is it going all over the place? Okay, what if I reduce the learning rate to this? So it should be 1 and 2. Ah, here it is. Okay, so we overshoot, it seems. We overshot with this dataset. Wow, it really went over the rate just there. So why is this happening? Why is this happening? Why is this happening? Why is this happening? Okay, okay. So ChatGPT has a great explanation. So what is happening is let's say we are here and we want to reach this point. But for some reason, we have a large step, so we overshoot and we somehow keep dropping and we never settle and we keep bouncing worse and worse. So a small step that we just created helps us walk slowly and carefully towards the minimum. Okay. Okay, let me now revert all of this. Bum 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 bum. And now if I print data at the end here, wait, this one is also overshooting by a lot. Why? Why is this one also overshooting? Is it overshooting? Yeah, it is overshooting. Why? What am I doing wrong here? Am I doing something wrong? What if I run this again? Okay, now it's okay. It's most probably cached some values or something. Okay, this generates this figure. So we have the size. We have the subplot, plot gradient descent. So it's this right here. No. So I want to, okay. So this is what happens if you have a different ETA here. So this is the figure size. This is the subplot. Why is it here 131? Adds an axis to the current figure, retrieve an existing axis. Yeah, but why is it 131 here? What is the argument here? Three-digit integer. The digits are interpreted as given separately as three single-digit integers. So fig adds subplot is the same as fig adds 235 is the same as figure adds subplot 2, 3, 5. All right, so I just created a subplot of some kind, it seems. Okay, I'm going too deeply into this, often than not. Too deeply. Let's just skip it. So I'm creating one subplot, two subplots, and I'm creating another subplot. And then I plot on each of these subplots. I have the theta here, and I have an ETA of 0.02. Okay, and I assume we have a gradiently colored lines here. So the red ones are the latest ones, most probably. Let's see, let's make this sure. So this is the Y label. Okay. Most probably we're gonna also have the X label somewhere. X label, it's here. X1, X1, X1. Okay. So, I mean, nothing much. This is the number of epochs that are being shown. So the same thing, we run all of this. We run all of this if the number of epochs is less than the number shown. So if the number of epochs is less, if epoch is less than number shown, less. So what, will this plot only the first 20 of those? Why only the first 20? But why is... Wait. Print epoch. Epoch. Number shown. But why am I running this multiple times? Ah, I'm running it. Oh, I'm an idiot. I'm an idiot. I'm an idiot. I'm an idiot. I'm running. I'm running it 3 times for each of the plots. Now here, if I print this, we'll have 1 to 1000, right? 3 times scrollable. 900. I'm gonna have 900 here, and I'm gonna have 1. I'm gonna have another one. But shouldn't it be? Yeah, I need to show 20 of those, but I want only to show them in the last couple of epochs, right? Because these are the most important ones. Maybe if we draw the last 20 lines, maybe the graphs would be too diverging into a certain point, so it won't make a lot of sense. Yeah, because the loop runs for 1000 epochs, but we only draw the first 20. Yeah, these are the only that are visualized. Ah, yeah, this makes sense, because after 20 of those, the predictions start to converge and all the lines would overlap. Makes sense, makes sense, makes sense, makes sense. Yeah. This one is the best, it seems, because it only in a few epochs, it already converged to the solution, to the correct solution. But on the right, the learning rate is too high, the algorithm diverges, it jumps all over the place. It's actually getting further and further away from the solution at every step. All right, now, we have another chapter coming up, and this is called the stochastic gradient descent. Okay, let's do some theory now. How much are we streaming? 1.5 hours. I'm gonna cut some of these, so if you watch this video and you say this is not this point in which you said 1.5 hours, it's not 1.5 hours because I cut some of this. I apologize. Okay, we are here. How do you even write stochastic? It's stochastic gradient descent. Just a second. So, what is stochastic gradient descent? So, I'm saying so a lot of times. It's my ultimate stopping word. Batch gradient descent. At each step, inside batch gradient descent, we use the entire training set to compute the gradient, which is the direction to move to reduce the error. This is accurate, but it's slow, especially for large data sets. So we have stochastic gradient descent. Instead of using all the data at once, stochastic gradient descent picks just one random training example at a time to calculate the gradient. Okay, just one. It makes each step much faster, but also less accurate. So we are trying to learn, again, let's move to this example. We are trying to learn 2x plus 1. So if we have this, if we have the data, this is a formula, we don't know the formula just yet, but I have 1 and 3 and 2 and 5 and 3 and 7 and 4 and 9. With batch gradient descent, at each step we look at all 4 points. We compute the error and we update our weights, theta. It's very accurate, but it's slow if the data set is big. It has a lot of rows. That's gradient descent. But with stochastic gradient descent, we pick one random point. So let's say we pick up 3 and 7. So we compute the error between our model's prediction and the actual y value. And then we update the weights based on just that one point. And then next thing we can pick up this one. We update again. Oh, we update again based on that point. So again, it's faster, but it can be noisy. The model might zigzag instead of smoothly going downhill. So why do we use this? Why don't use batch gradient descent? Because let's say this is the, I don't know. Let's say this is one of the local minimas. The smallest value in a certain section. So if the cost function has a local minima, batch gradient descent can get stuck here. But with tchdy, because it jumps around, it's a lot easier to first of all find the ultimate minima and to jump out of these local minima traps and eventually find the real global minimum. Okay. Okay. Let me go back here. Now let's do the code. Theta path tchdy. We need to store the path of theta in the parameter space to plot the next figure. Okay. Let's run this. Okay, we have this code. Let me just go over it quickly. Okay, 50 epochs. T0, T1. What are these? Some hyperparameters, okay. Learning schedule. I returned T0 and I divided by T plus T1. No idea what this does. Okay, this is a random initialization of a theta. Okay, this generates the figure. Okay, number of epochs for 50 epochs. And for iteration in range M, where have I picked the M? Where is M from? Ah, it's the size. Okay. Okay. This initializes, as I said, the parameters, intercept and slope randomly. This here defines the learning rate schedule. So why is this happening? Learning schedule. Where am I calling it? I'm calling it here. M. So as t increases, the learning rate becomes smaller and smaller. Okay, this is used to generate the figure. I don't need this. And random index. So this will run 50 times. But why then are we running this? Why am I running this in this size? M, what's M? What is M? Print M. 100. Yeah. So why do I run it 100 times again? All right. This just plots the new line. But here I'm getting the random index. I'm getting the random index. Okay, and I'm pulling data from the random index. I'm calculating the gradients. I'm improving the ETA. Yeah, I guess this picks a random data point for this iteration. I don't want to rely on the whole batch. That's why I'm using the stochastic gradient descent. Yeah, this selects one row of this. The only question I have is why do we iterate through M? Why do we iterate through M? That's the question I'm having. But first, let's do an example of this. Let's do an example of this. So what do I have? Oh, this is too blue. This is too blue. Maybe this one? Yeah. X is 1, 2, and 3. And Y is 3, 5, and 7. So same spiel. The linear function in question is 2x plus 1. So we need to add a bias term to x. So x with bias. I just realized that underscore b means bias. We are just going to add 1 to each of these. It's going to be 1, 1, 1, 2, and 1, 3. And let's say our theta again is 0, 5, 0, 5. So we are iterating through sample by sample. So we do, why do we iterate through M? Because we do M random updates, and each update is based on one randomly chosen sample. Okay. So let's say we have the random index here. Random. So random index is 1. Okay. So if random index is 1, I'm picking the x from the random index, and it's gonna be is gonna be, because I'm pulling from the X with the bias, it's gonna be 1, 2, and Y on this index is gonna be 5. And then we do the prediction, because here we multiply X, the index, with the theta. So I'm gonna do XE with the theta, and it's gonna multiply 1, 2 with 0, 5, 0, 5, and the value will be 1.5, only one element. Wait, where are you? Here. All right, so our model thinks that the value should be 1,5, but the true value for 2 is 5, right here. Okay, what else do we have here? Then we, where's the error? Ah, yeah, here we calculate the error, because the model is way off. Instead of 1.5, I'm doing 1.5 minus 5 is minus 3.5. So it means that the model is way off. It's predicting 1.5 instead of 5. So next we need to calculate the gradients, and we're gonna just plug these values in this formula that we have here. So I'm doing a transpose of xy, blah, 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 blah. But the values should be minus 7.0, minus 14.0. Wait. So this tells us how to adjust the weights to reduce the error. A negative gradient means you predicted too low, increase the weight. And then what I'm calling here, learning schedule. Ah, all right. Okay, then we update theta minus ETA times the gradient. So this is a different formula. Okay. No, I don't want to close this. Go back. This is a different formula for this. 2 hours in, boys and girls. 2 hours in. Let me just think, what are we gonna do next? And we're gonna do something next. Okay, what I wanted to do now actually is, yeah, I'm done with machine learning, but wait, it's one. I have a link somewhere in my bookmarks. Oh, but where is it? Where is it? Ah, here it is. Wait. This is what I wanted to do. Master programming by recreating your favorite technologies from scratch. I actually already built my own Lisp programming language. Is there a Lisp? Build your own emulator and build your own programming mesh. I think this is the book I used. Yeah, this is the book. That's really good. If you want, you can read this book. If not, you can watch my video on it. I have a playlist on my channel. How to make your own Lisp interpreter. You can tell it's a classic because almost no one read it all the way through. Yeah, makes sense. But I want to create something from scratch. From scratch. From scratch, from scratch, from scratch. Code crafter SIO. What's this? Become a better software engineer. Build shell from scratch. See the 2-minute demo. I don't care about this. I don't care about this. Pick a challenge. What challenges do I have? Build your own Redis. Oh, cool. So they have steps for this. This challenge is free until... How does this work? Okay, I need to log in. I don't start here to learn how the challenges work. This is actually a pretty good way to learn, but man, there's no way. I mean, maybe it is. I don't want to say that it's expensive because I think it's really useful. Build your own shell, build your own grep, build your own BitTorrent, build your own DNS. This is really cool. This is really, really cool. Okay, okay. What can I build? Game. Build your own game. Handmade Hero is currently on hiatus. The original set of daily source code. No thanks. Table of contents. Is there anything interesting here? Performance over programming series. Okay. Let's make Dangerous Dave. So this is a YouTube playlist. So what I want to do, I want really to make my own game. But first, maybe we can just finish a tutorial on something simple. So let's do this. No, I don't want to do JavaScript. Roguelike. Okay, maybe this is what I want. Maybe this is what I want. Making games with Python and Pygame, roguelike tutorial revisited, developing games with Ruby, build your own Git, interesting, but let's do the game one. Setting up. So what's the difference between this and this? Written in Python 3. And what is tchdy? Ah, it's original C library plus all of its ports. Transportation corridor overlay district. Okay. Okay. Okay, let's see how this will work. I'm really hyped for this. 2 hours and 15 minutes. Nice. A more traditional look was this. Okay, I know Python installation. You'll need Python version 3.7 or higher. I have it. I have Python. Okay, latest version of tcod. tcod. Okay. Okay, I don't need this. What is tcod actually? Windows, I don't care about Windows. Linux. On Linux, Python tcod will need to be built from source. You can run this command to download Python tcod's dependencies. Ah, so tcod is a free open source library designed specifically for building roguelike games. It provides tools to handle console-based rendering, field of view algorithms, pathfinding, procedural map generation, keyboard and mouse input, random number generation. Okay. Okay. So let's set this up. Where's my terminal? This, I can close this. Anything else of interest here? No. Terminal. New window. I'm gonna move you here, you beautiful bastard. Okay, let's go to projects. Let's create the game. The game. While you can certainly install tcod and complete this tutorial without it, I'd highly recommend using a virtual environment. Yeah, this is what I wanted to do. Okay. Okay, let's first create it. Okay. All right, I'm already here. I need to create the virtual environment. Python 3 when source when bin activate. Now we are, wait, let me move this down and what let me close this for now. Okay, now pip install tchdy. I have no idea what tchdy is, how it works. It's my first time ever even thinking about it. Okay, pip freeze, wait, requirements txt. Now if I say requirements txt, I have all of these things. What do I have here now? I have requirements. I should also create a main file, right? What is the tutorial telling me? To verify, okay, let's use Visual Studio Code here. Main py. So let's test this. I'm gonna copy all of this. I'm gonna paste it here, and now I'll write Python main py hello world. Okay, nice. For this tutorial, we need an image file. The default one is provided below. Right click, open. Why is this so small? This is supposed to be this small. Oh. Okay, so it is a small image. It is a small image. Save it. Okay. Okay. Oh, there's also a subreddit for this. Wow, 60,000 people. Is this a yeah, this is a tutorial that I'm following as well. What? Cool. This is really cool. Okay, let's do step one. Drawing the at symbol and moving it around. Let's do this. So this tutorial is largely based off the one found in Rogue Basin. And what is Rogue Basin? The roguelike information resource. You can edit. So like a Wikipedia for roguelike developers. Okay. So this is the main file. You can run the program like any other Python program. For those who are brand new, you do this by typing Python main py in the terminal. All right. If you have both Python 2 and 3 installed on your machine, you might have to use Python 3 main py. Okay. Or you can run the program by typing main.py. If I have it in my virtual environment. Wait, so I didn't know this. Clear main ls main. You are lying to me, my friend. Shebang. Main.py. Yeah, you're lying. I need to change the permission, so actually it would work. Hey. Okay, not the most exciting program in the world, I admit. But we've already got our first major difference from the other tutorial, namely this funky looking thing here. So I need to update this. What does this do? We're saying that we're only going to run the main function when we explicitly run the script using Python main py. It's not super important that you understand this now, but if you want a more detailed explanation, this answer on Stack Overflow gives a pretty good overview. Okay, let's get a net character on the screen. None. I have the screen width, it's gonna be 80. I have the screen height, it's gonna be 50. Tile set, tchdy. Tile set, load, tile sheet. What's the name of this guy? Deja vu. You just rename it to tileset.png, and this is gonna be tileset.png. Fuck. No! Oh, I hate this. 32.8 tcod tileset. Okay. We are loading this image. 32 by 8. What does this mean? Is it 1, 2, 3, 4, 5, 6? Yeah, I assume it's gonna be 38 places there. And here we have like 26, right? 26, 26, 27, 28, 29, 30, 31, 32. Okay. With tcod context, new terminal. Wait, does it have the context? Context, new terminal. It's deprecated. It's deprecated. Okay, I need to check the documentation here. So things have changed, my friends. So I need to create a console, tchdy console. So I have the width, I have the height, border is gonna be F, and now width tchdy context. Every time when I try to do something, my columns is screen width, rows, screen height, tile set, title, yet another roguelike. And then I have we think is true. Okay, so is this the context as context? While true, I'm gonna say console clear, console print 1 hello dungeon. Context present console. Why is this not working properly? What? Why? Oh yeah, I'm missing all of these here. Okay, now it works. Context present console for event in tchdy event wait if event type is oh man. Race system exit else if event type is key down if event sim is equal to tchdy event k wait k escape. Is this working? Let's see. Race system x system exit. No error. X what? Exit. So now if I run this, cool. So how do I call it? F C. How do I exit it? Wait, I should also see. Okay, you know what? Let's close it here. I'm a bit tired. I need to edit this video. I need to upload it, and tomorrow I'm gonna continue. Thank you all for watching, and see you some other time. Bye.